Alright, so we have this problem that says that the U.S. Post Office will accept a box for shipment only if the sum of the height and the girth around the bottom is at most 108 inches. So, it's asking us to find the dimensions of the largest acceptable box with a square top and bottom. Alright, so in any problem, we should start by drawing a picture. So this is the square top. This picture's kind of bad. Okay, so let's define our variables, right? So let's have x be the top and the bottom. And I'll indicate this as L and W for length and width. And so here's our length and width. And now let's have y equals our height. So now we can form a new equation from this. So the volume would essentially be length times width times height. So we have x times x times y. And if we clean this up a little bit, this will be x squared times y. Alright, now I have an equation. So now we can use y plus 4x equals 108, which is the maximum it can be. So our next step is to rearrange this to find y. So this would be y equals 108 minus 4x. Alright, so now we have our y. Now it's time to plug it back into our original equation. So v equals x squared, and then plug in y, 108 minus 4x. Alright, so now let's distribute everything in the parentheses to x squared. Oh, whoops, sorry. So this would be 108 x squared minus 4x cubed. Alright. So now our next step is to find the critical values. So in order to do this, we have to set this after we take the first derivative. Oh, this should be a 3, sorry. Alright, so if we were to take the first derivative of this equation, it would be 216 x minus 12x squared. And we gotta remember to set this equal to 0. And so with this equation, we can take a 12x out of each. So let's rewrite this. Oops, squared. So 12 divided by 216 is 8. Oh, sorry, 18. And of course, 12x divided by 12 leaves you with x. Equals 0. Alright, so from here we can see that our critical values are, I'll abbreviate that as CV, are 18. Sorry for my writing. And so what this tells us is that it is the maximum value that it could be. So now that we've found 18, we know that x has to be at least 18. So I'll indicate that by xm for max is 18 inches. Alright, so now that we found our x, we can plug into our y equals 108 minus 4x equation. So let's rewrite it. So y equals 108 minus 4 times 18. Now let's do the arithmetic for this. 108 minus 4 times 18, which would be 72, sorry. And do some simple math, and that should leave us with 36 inches. Alright. So this is our y. This is the maximum value y can be, 36 inches. So ym equals 36. Alright. So this is our final answer. And if you wanted to find out the total volume of the biggest box, essentially what you would do is just plug these numbers into our original equation, v equals x squared y. And that's it.